In step 1, you must clean the component for at least 20 minutes to eliminate any residual traces of coolants, cutting fluids, and corrosion inhibitors from the part. Then, in step 2, the component is rinsed for approximately 1 minute in flowing fresh rinse water. In step 3, the component is conditioned and pH balanced in a mild phosphoric bath for 15 seconds. The acidity of this conditioner compares to that of cola soft drinks. Next, in step 4, the component is rinsed again in clean running tap water to further neutralize the pH of the solution thereon. In step 5, the actual blacking tank, the component is immersed for less than a minute in a mild phosphoric blacking bath, where molecules of iron are removed from the surface and replaced with a microscopic copper phosphate, which is catalytically oxidized black. The component can be examined after about 15 seconds to ensure that the color is changing uniformly. During the remaining time, the component is blacked to about 90% of the desired black. The finish will go to a deeper black when coated with the corrosion inhibitor and allowed to dry. After about 1 minute, the component is removed from the blacking tank. Step 6 involves rinsing again in a fresh running tap water to neutralize any mildly acidic waters that are on the component and impermeate it into the black structure. Finally, in step 7, the component is immersed in dewatering oil corrosion inhibitor, which penetrates and displaces any acidic waters on and within the component and leaves the black structure impermeated with film-forming corrosion inhibitors. After 20 minutes in the corrosion inhibitor, the components are removed and allowed to air dry and cure for about 45 minutes. Mini-scale systems are available for the small job shop, whereas production scale systems are enhanced for performance. The production scale system involves the following: a cleaner, a drag-out rinse, an agitated rinse, a 15-second pH conditioner, another rinse, the actual blacking tank, a final rinse, and then a corrosion inhibitor and a drying area. Again, we have an alkaline cleaner, a static drag-out rinse, an agitated water rinse, a 15-second pH corrector, another agitated water rinse, the actual blacking tank, a final water rinse, and then the corrosion inhibitor, and a drying area. In the heated alkaline cleaning tank, the solution is slightly agitated by means of a simple mechanical pump. This agitation improves and hastens the cleaning. Then we have a drag-out rinse, which knocks the majority of the soap from the component. A simple pump as well agitates this water. Next we have an agitated tap water rinse, which is filtered through an optional rinse water recycling system. This rinse is agitated with approximately 2 to 3 pounds of compressed air, controlled and directed to the bottom of the tank. The blackfast rinse waters could be directed to the sanitary sewer without any environmental concern. After rinsing, the component is pH corrected in a slightly acidic conditioner for 15 seconds. After pH correction, the component is further rinsed and neutralized before actual blacking. This rinse water is recycled through charcoal to remove soaps and surfactants, and then is returned to the previous alkaline rinse tank. These two rinse tanks, one of which is mildly alkaline and the other mildly acidic, are very simply joined together for pH balancing and neutralization. After neutralization, the components are immersed into the blacking tank. The blacking tank is filtered to remove a normal iron phosphate precipitate, which is characteristic of the blackfast blacking process. The solution is simply pumped through two 20-inch polypropylene filter cartridges and returned to the tank. After blacking, the parts are rinsed again for 1 minute in another rinse water, which is optionally filtered through an economical 2-stage charcoal deionization filter unit. Finally, the components are submerged in a water-soluble dewatering oil corrosion inhibitor and allowed to air dry. This is a typical blackfast production blacking system. Now we'll take a look at an actual blackfast production run. Here the components are being removed from the hot alkaline cleaning tank. The components are next rinsed in the drag-out rinse tank, where the majority of the dried-on soap is loosened and removed. Then the components are rinsed again in an agitated rinse tank to remove the remainder of the alkaline soap. Then the components are conditioned and pH corrected for up to 1 minute in a mild phosphoric conditioner. After conditioning, the components are rinsed again in running tap water to further neutralize down the solution thereon. In this application, the components are given one final rinse prior to blacking. The prepared components are next immersed into the actual blacking tank, where molecules of iron are removed from the surface and replaced with a copper phosphate, which is oxidized black with selenium. After 1 minute in this tank, the components are then removed. The components are given one final rinse prior to being immersed into the corrosion inhibitor dewatering oil. The components are left in the corrosion inhibitor for approximately 5 minutes and then are removed and allowed to drip and air dry. The blackfast room temperature blacking process affords 10 to 20 times the corrosion protection of the traditional hot black oxide system.